All right, crew, this is the last geometry lesson for the week. So this is focused in on area, the other basic calculation you'll find regularly in geometry. So area, to go over the definition, that's what I like to refer to is the space inside a figure. And it's often boxed off, okay? Even though you don't always see the boxes, it's also kind of defined as the square units inside a figure. So that's where we get the idea of square units. Now the general formula to calculate that still, when you're looking at standard shapes, nothing irregular, still deals with length times width. So if I look at this figure down here to the left, you should remember from elementary school, when we are looking at figuring out the space, this yellow area inside, if we divide it off into square units, we come up with array, which means the operation of multiplying. So we are taking the length and we're multiplying it by the width. So again, for units, because you're talking about squares inside of a figure, any kind of label that you see needs to also include square or a little 2, this little exponent of 2. So take a look at the examples here below. So we have a 4 and we have an 8. So again, our general formula tells us we're going to multiply those. So whether you can do that in your head or you need a calculator, either is fine. We have 32. So as far as units, centimeters, and because we're looking at area, we're looking at square units inside, you can use SQ to represent square, or you could use centimeters and put an exponent of 2. Either is fine. Taking a look at number 2, you don't see the squares inside, but you should, if you're asked to find area, you're still multiplying those two values. So 4 times 2, 8 kilometers, and I'm going to use the little 2, the exponent of 2. Okay, again, sometimes you're just given the length and width measurements. So those are the easier types. You can just assume it's a standard shape, that it's a rectangle or square, and simply multiply. So if I'm looking at this first one on the left, 3 times 6 to find my area, 18 inches. And I'm going to do it differently this time. I'm going to write the SQ to indicate that I know an area. We're talking about square units inside. And the other one here, 8.5 times 4. Again, you may not always be able to do the math in your head, so feel free to grab a calculator, and even it's never a bad idea to check your work. So when you multiply 8.5 times 4, you get the answer of 34. And again, this time I'm going to use the label SQ to indicate square units, but make sure also to include your general units, in this case, centimeters. Okay, irregular shapes. Irregular shapes are typically shown on a graph, because again, we're talking about square units. So we are looking at, in this first one on the left, each box is 1 centimeter. So if we're talking about how many square units are inside, in this case, you're going to just add them up, guys. So you're going to go and say 1, 2, 3, 4, 5, 6, 7, 8, and so forth until you get the area of your figure. So if I kept going 8, we have 14, 14 centimeters. Sorry, guys. And this problem, I'm just going to use the 2. Now, there's no rhyme or reason to when I'm using which label type. I'm just showing you both versions so that you can see that both are completely acceptable. So in the second box, a little more challenging. They're not all whole boxes, okay? So you, again, are going to be counting them up, but you can also put boxes together that equal the value of 1. So again, this example, it's referring to each box as 1 centimeter, so you're going to count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So if you noticed, I went straight for the whole boxes first, and I have 17. Now you should notice that these are 2 halves. I could put 2 halves to make 1. So if I was at 17, these two together bring me up to a total area of 18. So in this example, I have 18 centimeters squared for my area. There we go. All right, similar kind of concept with this last one. Again, you're going to be counting the boxes. So whole boxes first, you should notice 3. This makes 4, and this is a half, so 4.5 for the area of this last one. So again, you can have half boxes, just calculate that in your answer. And this last one, I'm just going to go back to my SQ. So whatever's easier for you guys, as far as labels, works fine. Okay, the other portion of area is those were all what we've looked at prior to this was all about basic square figures and rectangles. So what if you have something that is slanted? This is called a parallelogram, which is a slanted square or rectangle, as I mentioned. So to calculate the area for these type of shapes, we have a slightly different formula. Follows the same concept, but we're going to be looking at areas of the calculating areas of parallelograms by using the formula area equals base times height. So base times height. You might also see it without the multiplication sign in there because it can kind of look confusing with a bunch of letters. Two letters buddied up together, you should have remembered from algebra, also means the operation of multiplication. So taking a look at some examples, sometimes you're only going to see the information you need. Other times you're going to have to figure out what numbers we need. Okay, so taking a look at some examples here at the bottom, again, your formula is area equals base times height. So taking a look at those variables and describing what they are, your base is typically the number on the bottom of the figure, or it can also just be kind of the horizontal value. The horizontal value is typically your base. And the height is the value that it stands straight up and down. So I always think of height is that if you're going to measure how tall somebody is or what is their height, you would be looking at them to stand straight up and tall and definitely not be slanted. So for parallelograms, you're basically ignoring the slanted value. Okay, so if I take a look at the specific examples here at the bottom, we have just two numbers. This would be considered my base, the horizontal value, and my height is my straight up and down value, which this is the only other number we're given. There's a nice arrow to it that tells you it's 2 centimeters. So again, the operation is multiplication. So 6 times 2 gives you the value of 12. Now we're still looking at area. So the squared units are still required. Easy to forget, but try to remember. All right, the middle one. So again, we've got more numbers in this one that we actually need. So we're looking for the base, that horizontal value, and then that vertical straight up and down height. So the first thing that I ask is we look for this information. Here is my base, 4. Height, we've got two choices. So if you remember me saying we're never using the slanted, you would never measure how tall someone is by asking them to slant over. You always stand nice and straight, so you're the tallest you can be. So those are the two values that we're multiplying together. 2 times 4, 8, and this time I'm going to use square, it's meters, square meters. The last one, again, I'm giving a little bit more information than I technically need, so take a minute and identify your base and height. This one is your base, it's my horizontal value. And as far as my height, I've got a choice of 2 or 1.8. 1.8 is the value that we're going to be looking to use because, again, it's standing straight up and down. And when we're measuring height, that's what we're looking for. We never, ever, ever use the slanted value. So multiplying those two values together, you get 4.5. Put my squared label with it. Okay, last but not least, if you're just given the measurements, super easy. This is the easiest type. You look at them and you multiply them. We have the height measurement and the base measurement. So again, we multiply. The biggest thing is that you remember to include your labels. So this one is feet squared, square feet, same thing. This one here in the middle. And if it's decimals, you might be best to grab yourself a calculator and complete your calculations that way. This gives you 18.2. Hi guys, rule of thumb. I had mentioned to you before, when you see decimals in a problem, good chance your answer is going to have decimals in a problem. If you do not have decimals in the problem or fractions in the problem, whatever it may be, your answer won't have that typically. So you always want to look at what you start with and see if it logically makes sense. It's a good also way mentally to check your work. So the last one, again, I'm just multiplying those values together to get the area of the figure. Okay, well that's, like I said, the last lesson. There is an attached assignment for you to complete that focuses on the area of general figures and then the area of parallelograms. Good luck and reach out if you need any help.